Welcome back, everyone, to the eCoreAcademy e-learning platform. Today, my name is AJay back with another geometry video for you all. Today's lesson is all about parallel lines and transversals. Before we jump into today's lesson, please make sure to smash that subscribe button down below, hit that like button on this video, as well as turning on post notifications to get notified on any of our channel's latest posts at eCoreAcademy. All of those things are very greatly appreciated. As I said before, today's topic is all about parallel lines and transversals. We're moving away from some previous topics that we've come across, but we are still going to refer to some previous topics learned in some of my more recent geometry lessons. This is more about angle relationships, and it's going to be about line intersections, which creates angles of various different relationships amongst each other. So today's the whole purpose of this lesson today, and the whole theme of today's lesson is to discover what are the different angles created by a transversal intersecting two parallel lines, and what exactly are the relationships. So it's about two parallel lines given on any graph, and we're going to see when a transversal, which I'll explain later, intersects those two parallel lines, what are the different relationships among those lines, and what exactly happens between the angles of intersection that are created. So let's jump right into it. So let's look specifically at parallel lines and transversals. Those are two, one of them you've already known, parallel lines, very basic concept. Those are two lines with the same exact slope, and they have never have any intersection for their entirety of their length, and they're two different lines, and they both have the same slope on a graph. So they are expected to have the same exact length because all lines have the same length. But now let's look at exactly what transversals are and what relationships they create when intersecting two parallel lines. So let's look at transversal intersection. So a transversal is a line that intersects two or more lines in a plane. So as the definition states, it's a line described on a plane, which is a two-dimensional outlook on a 3D overview. And basically, it intersects two separate lines. But the specific type that we're going to be looking at today is a transversal that will intersect a parallel line. So when a transversal passes through two parallel lines, which is a specific pair of lines, as we can tell, you can have any type of lines, and a specific relationship amongst two lines is being parallel. So when a transversal passes through two parallel lines on a plane, special pairs of angles are created that can be used to solve problems and prove theorems. So this is an example of that. So you're given your line L here. I'll circle that here. So this is one line. And this is your other parallel line. So these two lines are parallel to each other, and those parallel lines are shown on a plane. And then you see here, this is another line, our transversal here. I'm going to mark that with a tick mark, just to represent transversal. And so our transversal is intersecting these two parallel lines given on your two-dimensional outlook, your plane. And when it does that, you see these different points of intersection. These different points of intersection actually form different angles. And we're going to try and see what kind of angle relationships they actually form amongst each other, and of course separately, what type of specific relationships you have with the specific degree of intersection a transversal creates on parallel lines. So let's look at angle relationships now. As we first looked at transversals intersecting parallel lines, we'll see what those gaps actually develop in forms of angle relationships. So let's look at corresponding angles. That's our first angle pair relationship. So corresponding angles are angles that lie in the same position or match up when a transversal intersects two lines, meaning it does not necessarily have to be a set of it does have to be a set of parallel lines. And the reason that I'm saying lines is because I just want to emphasize it has to be parallel lines. We've already made a whole purpose that transversals that we're going to be looking at now, and mostly throughout geometry, is only going to be towards parallel lines. So basically, it's angles that lie in the same relative position. When two transversals intersect, you're going to see two different sets of four angles, and 8 different angles are made, and two sets of four pairs of corresponding angles. So if you look here at this transversal intersecting these two parallel lines on this plane as shown, you can see that there are relative positions here. So angle 1 here is in the same upper left hand corner as angle 5 in this sequence here. So angle 1 and angle 5 are in the upper left-hand corner of the 4 angles given in each line intersection that the transversal intersects both lines, at the intersection of both lines. And then 2 is corresponding to 6, so 2 corresponds to 6, and then 4 corresponds to 8, and of course 3 corresponds to 7, and 1 corresponds to 5. And if you memorize what I've just shown you here, if you memorize this relationship, these pairs, all you need to do is when you're given a transversal intersecting parallel lines, most of the time they're going to be labeled with numbers just as shown here. All you need to do is look at those numberings and just match up 1, 5, 2, and 6, 3 and 7, 4 and 8, just a number of 4 difference between those two values. And if you memorize that pattern, you can just keep that consistent for any problem coming up. If they're symbols, you just have to memorize the positioning. Very easy concept as shown. And the way that I've organized this is I'm going to be showing you all of the different pairs that are created, and then I'm actually going to show you the different theorems of all those different pairs and show you exactly what those relationships are. Next, let's look at angle relationships part 2, and we're going to look at alternate and interior angles, our second relation, our pair of angles. We're going to be only comparing pairs of angles. So alternate interior angles are angles between two lines that are not the transversal and are on diagonal opposite sides of the transversal. So if you think about alternate interior angles, you can almost think about opposite interior angles. So when the transversal intersects both of the parallel lines, they're on diagonal opposite sides of the transversal, but they're on the interior locations. So if you look at this transversal intersecting these two parallel lines, and in this, of course, examples are most important to show you here exactly what this diagram is representing. So if we look at angle 3 here, one of our interior, so if you look at this angle pair here of these four angles intersecting, one transversal intersecting this upper parallel line, you can see it forms 4 different angles, and you can see that on the outside of this parallel line, it's angles 1 and 2. And then on the bottom parallel line, 7 and 8 are on the outside. So those are your exterior angles. We're going to ignore them. So if we look at the interior angles inside, in between both of the parallel lines, we have 3 and 4 and 5 and 6. So we look at 3 and 4 and 5 and 6, we're going to draw diagonal opposites. So opposite interior angles. As you can see, 3 and 5 are on the same side, so they're same side interior. But if you look at 3 and 6, they're on an opposite side. And if you can draw a straight diagonal line connecting 3 and 6, making them alternate interior angles. And then finally 4 and 5, since they're opposite interior angles, they're going to be alternate interior angles. Same definition, same reference, sorry. So those are your alternate interior angles. And then for angle relationships part 3, we're going to be looking at alternate exterior angles, basically the complete opposite of alternate interior angles as stated in the title. So alternate exterior angles implying the very same thing, angles outside the two lines that are not the transversal and are on diagonal opposite sides of the transversal. So what we're going to do here is we're going to eliminate the interior angles, which are 3, 4, 5, and 6 in between the parallel lines, and we're going to specifically look to the angles outside, the exterior angles outside of the lines. So we have 1 and 2 and 7 and 8. So they're outside of the sandwich that the lines create. Just as an example, we have 1, 2, and 7 and 8. So that's 1 and 2. So 3 and 4 and 5 and 6 are out of the question because they're all interior angles. So we're going to look at 1, 2, and 7 and 8 and compare their relationships. So if we look here at 1 and 2, and 5, 7, and 8, we're going to do the same thing. We're going to draw a straight diagonal to opposite sides. So as you can see here, 7 and 2 are on opposite sides of each other, and if you draw a diagonal, they will match up. So that means 2 and 7 are alternate exterior angles, and then if you look at 1 and 8, they're on opposite sides, so 1 and 8 are opposite alternate exterior angles or opposite exterior angles. For angle relationships part 4, let's look at vertical angles. Now, I've already made a video on vertical angles as it's on its own, but if we look at this specific property, when transversals intersect parallel lines, it's still going to give, basically, it's where you derive the entire concept of vertical angles from, but we're just going to apply it to this scenario. So vertical angles are two non-adjacent angles formed by intersecting lines. So in other words, they're just opposite angles given on the same outlook. Two non-adjacent angles, those are basically angles that do not share a same side. So they do not share the same side, and only 2 pairs of angles in a 4 angle pair when a transversal intersects one parallel line, there will only be 2 pairs of 2 vertical angle pairs of those 4 angles, and they're going to be formed by, of course, your intersecting line. So if we look here, there's going to be 4 vertical angle pairs formed here. So if we look here at angle 1, just like I showed you in the examples before in my previous video all about vertical angle relationships, you can see 1 is directly opposite from 4, so these two are going to be vertical angles, and we know that vertical angles are always going to be congruent. So vertical angles, I'm going to write this down here. So vertical angles equal opposite plus congruent. All right. So now that we know that vertical angles are opposite and congruent, we can tell that 1 and 4, angle 1 and 4, are going to be vertical angle pairs. So I'll just indicate that with the circle, and then we'll put a tick mark over 3 and 2. They're vertical angles, and then if you look at 5 and 8, they're opposite angles, so they're going to be vertical angles. Non-adjacent, so they're also going to be congruent, and then 7 and 6 are also going to be congruent as well. So simple, just basically a review if you've already went in order of the steps of videos that I've already portrayed previously in my geometry course. And finally, for angle relationships part 5, let's look at linear pairs. So I've also shown you what linear pairs are, but linear pairs also apply specifically to this situation. So linear pairs are two angles that have a common side and the same vertex. So that's basically two adjacent angles, and their other sides point in opposite directions. So if you look here, what basically will form a linear pair is anything that adds to 180 degrees. And if you can see here, angles 1 and 2, they basically are the exterior angles of this angle pair here. They have one common side, one common vertex. And if you can see here, their bottom line, they both point in completely opposite directions, making 1 and 2 a linear pair. So any straight angles that you could see here, any angles that are directly adjacent to each other and are on the same description of interior and exterior. So your exterior angles of your 4 pair here on the bottom transversal intersecting the parallel line, as well as the top, are also always going to be a linear pair. So 1 and 2, linear pair. 3 and 4 are going to be a linear pair. 5 and 6, a linear pair. And 7 and 8 are going to be your linear pairs. Now let's move on to the angle theorems and postulates. Now that we've actually identified different relationships, different identifications, basically, we're going to actually show you what they actually mean. So we're going to look at, same side interior angles, all of these different relationships, just to identify exactly what's going to happen. So corresponding angles. So let's look at the corresponding angles postulate, which is basically a statement or a theory. So the corresponding angles postulate states that if two parallel lines are intersected by a transversal, then corresponding angles are congruent. We know that we have 4 pairs of those, 4 sets of those corresponding angles, because we have 8 total angles created by this intersection of transversal lines in parallel lines. So if we look here, we have angle 2 and angle 6. They are both obviously corresponding angles in the same relative position of intersection. And since we know by the corresponding angles postulate, we know that 2 and 6, which are corresponding angles, are going to be congruent because they are corresponding angles. We know that angle x here, the remaining whatever is remaining here, is going to be equivalent to 98 degrees. So 98 degrees, I'll write that here, 98 degrees. And likewise, 1 will be congruent to 5, 3 will be congruent to 7, and 4 will be congruent to 8. And this is one type of problem you'll come close to when trying to solve parallel lines and transversal problems. If you're given, the angle measure of 2, then you automatically know the angle measure of 6. Likewise, if you're given the angle measure of 7, then you're given the angle measure of 1, all under the corresponding angles postulate and the proper identification of corresponding angles. Let's move on to angle theorems and postulates part 2, which is all about the alternate interior angles theorem. So we're going to take the alternate interior angles theorem and formulate a theorem, alternate interior angles, and we're going to form a theorem all about them and their identification. So if we look at the alternate interior angle theorem, by definition, it states that if 2 parallel lines are intersected by a transversal, then alternate interior angles are congruent. So so if you can identify alternate interior angles, then you know that those pairs will be congruent. So if we look here, this is an example of alternate interior angles. Since they're both alternate interior angles, they will also be congruent in measure, meaning equivalent in measure. As simple as that, and those arcs are of the same number, meaning that there's singular arcs given in those angle measures, representing those angle measures, which represents congruency. Angle theorems and postulates part 3. Let's look at the alternate exterior angles theorem. And it states that it states that if two parallel lines are intersected by a transversal, then the alternate exterior angles are congruent. Just like the alternate interior angles, this is just basically like an inverse statement of that. So it applies the same properties. So if you can identify alternate exterior angles, just like angles 1 and 8 here, we know that 1 and 8 will be congruent because they're alternate exterior angles. So just like that, 1 and 8 will also be congruent. I'll just write that here by the angles here. So 1 and 8 will both be congruent. All right. Now, angle theorems and postulates part 4, let's look at same side interior angles theorem. So if two parallel lines are intersected by a transversal, then the same side interior angles are going to be supplementary. And supplementary basically means that these two angles will add up to 180 degrees. So if you can see here as an example, these two angles are given and they're both same side interior angles, meaning that they're going to both add up to 180 degrees no matter what. And you can use that for different problems. If you can see, if you get the value of 1, you just merely subtract it from 180 degrees to get the value of the corresponding same side interior angle. And finally, for angles and theorems and angle theorems and postulates part 5, we have important forms of proof. So this is going to be forms of proof, how it's actually going to be represented in a proof, actually be represented as proof, and what kind of postulates will prove another one. So anything that you do, any postulate or theorem that you have has to be based off of previously formulated theories that are actually proven, or actually previously formulated definitions that are under the laws of geometry. And you can use other theorems and postulates as proof for the theorems that you're looking at currently. So theorems and postulates can be proven on the basis of established definitions of properties, and those properties are given by the laws of geometry. So the corresponding angles postulate applies as proof for all other 3 theorems. That's because the corresponding angle postulate actually involves relativity, and it starts the relativity between angles to create corresponding angle relationships amongst all other angle pairs. So you can use that as proof for all other theorems and postulates that I showed you today. And yeah, you can show this in a 2-column proof, the most common way to do so. If you're doing a geometric process where you're trying to prove, I'm trying to prove same side interior angles are supplementary, you can use the corresponding angles postulate and the corresponding angle steps as your proof to actually getting there. So that's the only way that you can actually use proof to get there in a 2-column proof when trying to figure out same side interior, alternate exterior, alternate interior, any of those angle pairs. Yeah. All right, guys, so that'll be it for today's video. I hope you all enjoyed. This has been the eCoreAcademy e-learning platform today. Please make sure to like and subscribe down below. Hit the post notification bell to get notified on any of our channel's latest posts. All of those things are very greatly appreciated, like I said before. We put a lot of time and effort into that, and we really appreciate all the support that you've been giving us so far. Please make sure to visit our website at www.ecoreacademy.org. We work very hard to actually bring that up, and we're glad to say that it's a beautiful finished product for you all to view. We have all of our different perks and all of our different accesses given there. We have course studies organized into different courses, special events, organized structure, so it's easy for you to find out contact information. And in all of our courses, we have organized all of our YouTube videos in there, and we have guided note sheets, quizzes, and worksheets, as well as progress trackers that basically replicate it as a professional course entirely. Feel free to email us at eCoreAcademy@gmail.com. That's also found at our website as well if you have any questions or if you just want to reach out to us. And also, finally, please make sure to check the description box down below for all the links to our socials at Facebook, Twitter, and Instagram. We have all new content there apart from our YouTube channel. So check out all of our new content and use our Medium to share all of our videos to those who might need it and those who might find it interesting. Once again, everyone, I hope you all enjoyed. This has been AJ, and I will see you all in the next one. Peace.